talk of the day. We've got Ben Herzberg, who's going to be joining us and giving a nice little discussion on securing your Snowflake cloud warehouse. So by all means, thank you, Ben, for joining us and being our last talk of the day. I'll pass it over to you.
Okay. Doing a BSides talk from home. It's my first time, not my first BSides, but my first BSides from home. This is a photo from my last trip, I think, or one of my last trips before COVID. And we're going to talk about nicer things about Snowflake security today. A little bit about myself. My name is Ben Herzberg. I'm a security researcher. I'm working as a chief scientist for Satori. We provide protection, security, and compliance for data warehouses and data lakes. Before that, I was leading research for Imperva, and I have 3 kids. Hopefully, you will not hear them throughout this talk. And I'm from Israel, where it's not 4:20, it's 11:20. Though some say it's always 4:20. Here are my contact details in case anyone wants to ask anything. And of course, feel free to ask anything in the Discord channel. We have quite a packed agenda. So I have to say that some of this will be quick, and I may fast forward through some of the commands that I'm running, etc. But I can, of course, send all the code, the trend, all the queries, all the samples. I'm hoping that if you miss anything, we can fix that. So what are we going to talk about today? We'll have a short introduction, as I think that this is something that we should do. I'm sure that not all of you are well familiar with Snowflake. And we'll talk about 3 topics in Snowflake security. Obviously, we're not going to cover everything that there is to know. We're going to cover network access control. That's a small subject in Snowflake, pretty nice and simple. Data access control, which is a huge topic, and we'll have to be very focused in data access control, and logging and monitoring in Snowflake. So I'm hoping you will get value out of this, and we'll wrap it up with some takeaways. So the good thing about not having people in front of me, I can say, are you ready? And I can imagine that everybody is saying that they are ready. So let's start with some introduction. What's the prerequisites for this talk? So some of you have heard about Snowflake. Maybe some of you haven't heard about Snowflake. Some of you only heard that it's a cool technology. And some of you probably use it. So we'll have an intro specific, like what's Snowflake, what's a cloud data warehouse. And I assume that most have at least some basic SQL knowledge. If you don't, then just ignore the SQL bits and you will be fine, and focus on what we're trying to achieve. So a small disclaimer. As I said, you can. I'm not trying to say that by the end of this talk you will know everything you need to know about Snowflake security, but I do hope to spark your curiosity and give some ideas about better protecting Snowflake or other data warehouses. And remember that we are all unique, like snowflakes. Each organization is different, and not every access control setting is right for everybody. Otherwise, there would be no settings, and we would just have same configuration for all. But again, it's to spark the curiosity, to get you started. And okay, so let's start with Snowflake is a cloud data warehouse. Sometimes the terms database, data warehouse, and data lake, sometimes there are products that are in one category, and there are also other categories. The lines are a bit blurry, but database is usually OLTP. It's transaction. It's aimed at transactions. It stands behind applications, for example, e-commerce applications, and it does the database behind it. It's mostly structured data. It also can include semi-structured data. like JSON, but mostly structured data. A data lake on the other end, the rightmost column, data lake like S3, like Azure Data Lake, is the idea that anything goes in there. You flush all your data, the logs, everything. You're sending it to a data lake. You're sending it. Some of it is somehow structured, for example, in Parquet files. Some of it is in other formats, and then mostly data scientists, or forgive me for whatever job title it is, people are taking a look at this data and trying to make value out of it. I would say that data warehouse is something in the middle. The good examples are Redshift, BigQuery, and Snowflake. It has structured or semi-structured data. Its main usage is for analytics purposes. And in our days, where all companies are data-driven, mostly all of the companies are data-driven, many teams are making use of the data warehouse, and because it's very simple, structured, there's a schema, and you can get very good value out of it. You also have great BI tools to connect to the data warehouse and do your stuff in there. So you put also a lot of things in there, and you start getting value from your data. Snowflake is a cloud data warehouse. Perhaps you've heard about the IPO. It's the biggest software IPO of this year, or maybe of the last few years. And it's the fastest growing cloud data warehouse. So Redshift is the biggest, AWS Redshift is the biggest, but it's the slowest growing. BigQuery and Azure Synapse has good growth and are bigger. Snowflake is the smallest out of this pack, or out of this pack, but it has it's the fastest growing. It's a unicorn of a unicorn company. And there's a reason. It's a SaaS, simple, powerful, scalable solution. It also has some great features like a data marketplace or secure data sharing. It has dynamic masking built in, and tokenization. And once it's very easy to get from zero to Snowflake, and it's also once it's in the organization, the usage grows because lots of different teams see that it's very easy and the things are a SQL query away from you. So some of the security challenges around Snowflake, which are also true to other cloud data warehouses. First of all, the security in data warehouses is usually, and again, each organization is different, but not managed by security teams, but they're managed by data ops or data engineering teams, and whatever title it is that manages them. It's usually not the security teams, and this sometimes creates a gap because the security teams don't have the knowledge of in which table either the sensitive data that we don't want that team to have access to, etc. There's a blurry responsibility between Snowflake, the data teams, the security teams, and this is a challenge that we see around Snowflake security management. There are also compliance issues, which are, very, I would say, it's not correct grammatically, but very solved in the older data warehouses. With ready reports and everything, and in Snowflake they are a bit blurry, and also there is role hierarchy in Snowflake. It's an RBAC software, so it's a role-based access control, but it has hierarchy. So a role can also it can have its own privileges, but it can also inherit privileges from other roles, and in some organizations that causes complexities, and we'll talk about that later. So for the samples, I set up a fictitious company called papercatinator.io. This is a tribute to Phineas and Ferb, to Dr. Heinz Doofenshmirtz, who had a lot of band-aids to sell, so he set up a gadget to give people paper cuts. And so I thought, let's create papercatinator Snowflake.io will create a database, a schema, and some tables. Customers for the customers, and purchases for what the band-aids they are buying. So this is Snowflake UI. You can do mostly anything in Snowflake. So we're creating the database in the UI. So we're creating the database and the schema, and we're creating the tables and inserting some bogus information into the tables. Let's run it. Okay, my camera. Ooh. Okay, let's hope that it will be okay. And now we have the data, and so we can query the data. We're selecting customers. As you can see, we can get a nice view of our customers. Of course, they are fake customers. Don't worry. They have phone, email, date of birth, password. Okay, so now that we have our test data ready, let's talk about network access control. This is the first and quickest topic of today. Network access control, basically, it means limiting access to the resource, in this case, to the data warehouse, based on the network you're on. So you can, for example, limit access only through certain IP addresses like VPN, VPC, Office IPs, etc., etc. Why do we even want to do that? Because by default it's off, so you can access your account from anywhere, from any IP. So first of all, it's a risk reduction. If you don't allow people to access your data warehouse from whatever IP they are in, then you reduce the risk of them, for example, connecting from a computer that's not authorized and has malware in it. And so you can limit them by doing that. And you can also compliance, meaning that some of the compliance controls, the frameworks, require you to show that you place network access control on your data. So setting up network access control in Snowflake is very easy. It's you can set up policies, and we will do that in a while, and set a scope for the policies or assign the policies. You can set it either for the entire account or for a specific user. So it's very simple. There's no hierarchy of policies or anything like that. And of course, Paper Catinator with Dr. Heinz Doofenschmidt, they want it, and let's set it up. They want everybody to connect only from the office, except, of course, for the CEO, president, and co-founder Doofenschmidt, who wants to connect from anywhere. So let's set it up in Snowflake. So it's very simple. We can also do it from the UI, but that's not fun. So we'll just run the query. So we're setting the network policy office. We're defining it with an allowed IP list. It can have subnet in it, of course. And then we're setting the account to use Office. And then we're setting Heinz, a different policy on different IP addresses. Of course, use your imagination, and you can leave only the setting that allows all access, and we're setting it to Heinz, the user. So now we have the situation that we wanted, where everybody can access only from the Office IP. Of course, if I remove it, and Heinz can connect from anywhere. Please don't do that. Even if your president, CEO, and co-founder asked you for to bypass all security, please don't do that, as you will be the one staying up all night afterwards when there's a data breach. So don't do that. Some of the limitations around network access controls in Snowflake are it only supports IPv4, or it doesn't support IPv6, that is. And the identity granularity, sometimes it's not, you have to script your way around it, because an account level is very big. It's very blunt. And the user level is sometimes too granular. When you have thousands of employees or hundreds of people connecting to your Snowflake, there's no in between. So that sometimes is a limitation. It is a limitation. Sometimes it's very disturbing. You cannot set the access in the secureable object granularity, meaning it's a 0 to 1. You either are coming from the right IP addresses and you can go in, or you are not and you can't go into your data warehouse. You can't say, for example, that you can go into your data warehouse from a list of IP addresses, but to the HR database, you can only go from specific restricted IP addresses. And also you can't do network access control based on data types. For example, you can access information from any network or from a specific network, but to access PII, personal identifiable information, you can only do that from certain IP addresses. So those are some of the limitations. Let's talk about data access control, which is a big topic. Data access control means how do you limit people to use the data, either reading, writing, updating the data in the right way. And it's not a trivial question, not in Snowflake, not in other data stores, because on one hand, you want people to actually use the data. On the other hand, you don't want to be over permissive. You don't want people to have more access than they need, because that's a risk. And you don't want to become a rubber stamp that simply gets tickets and opens permission. So it's not a trivial subject, and we can discuss it later after the talk. Some of the terms you need to know about data access in Snowflake. There's the secureable object. That's the object we're trying to secure. For example, a table is a secureable object. A database is a secureable object. And a view is a secureable object. By the way, unlike, as example, Redshift, a column inside a table is not a secureable object. So that's a secureable object. For example, a table is the best example of a secureable object. You want to allow access to a table. A privilege or a permission, it's called privilege in Snowflake, is what can you do with the secureable object. It's like a tuple, the object and what you can do with it. So you can only read only, that select, use only select on this resource, or you can do update, truncate, delete, insert, etc., etc. So that's the privilege. And a role gets these tuples, these privileges to do stuff on different secureable objects, and that defines the role or what it can do. Okay, that's classic role-based access control. And the user, they are granted with the roles. So a specific user like Ben can have multiple roles. But for each query I'm sending, or for each command I'm sending, I'm using a specific role. And the privileges I have are based on that role. Hope that makes sense. If that doesn't, we can continue this after the talk. Why do we want to have data access control? Because some of organizations are very permissive and they're simply giving access to the entire data warehouse. So it's risk reduction. Again, if you're using data, then you're creating value. If you have access to data you're not using, you're getting the risk, but you're not providing a value. So ideally, you don't want people to have access to what they don't need. And compliance, of course, meeting regulations and security frameworks, being able to say which users can access which data, and so on. There's also privacy, setting access to PII. If you know that you have PII in specific tables, you want to set specific access to that and restrict access to PII. Sometimes, of course, PII is found in unexpected places. Okay, so setting up data access controls in Snowflake is pretty easy. You assign users to roles, You can do it manually, like grant a role to a user. But most organizations, of course, are doing that in an automated way where the groups are imported to Snowflake or interfaced with Snowflake, and they become roles, and the users are the users of those roles. So, for example, with Okta integration. So the first part is pretty easy. It's mapping the users to the roles. The second part is a bit trickier. It's granting the objects to the roles. That's a part that is tricky because not always is it very simple to know exactly what data everybody needs, etc., etc. But that's a topic for a different talk. So that's it. That's what you need to do. And of course, Paper Catenator wants data access control. And they have two roles, packing samurais and packing ninjas, and they want these roles to inherit. You remember there's a hierarchy, inherit from the packing role. So the packing allows to select data, only to retrieve data from customers, so we know where to ship, and from purchases, so we know what to ship. Let's see that in Snowflake, and we'll create a role packing, okay? And let's assign it to our role and grant usage for the database, for the logistics to packing role, and to all the tables in logistics. And now we're creating the two child roles. We're doing this just to show that hierarchy works and that it's fun. I don't know if it's fun, but it works. And then let's try it out. As you can see, let's use the packing ninjas role. You can see up here that we're now using the packing ninjas role. And now we can select data from this table, from the customer's table. Pretty sweet. Now, let's say there was an audit on papercatenator.io, and they're saying that the packing teams are risky. Why? Because they're accessing PII. Some of it they need, but some of it like date of birth and passwords they don't need, and we want to restrict them from that. So let's limit the access. What we're going to do is use views. And a view is basically giving partial access or full access to underlying objects. So basically, it's you can think of it as a virtual table that you can filter on top of existing tables. You can filter, you can join. Sometimes you use it for operational reasons. Sometimes you use it for security. In this case, we'll return to the account admin role. And this is a demo account, but in your account, do not use account admin. You should not do that. This is just a demo account. And what we're doing is creating a view that selects only the columns we need from customers, okay? And then we are revoking the access to customers from the packing roles, from all of the packing roles, and we're giving it access only to V customers, which is the view we created. Hope you're with me. Let's go back to the samurai, the ninjas, packing ninjas role. And now you can see that when you're retrieving data from the view, you're not getting the date of birth or the password. And when you're retrieving data from customers, you're getting access denied. So you can't access the data that you're not supposed to access. And this was done using secure views. I will not go into details around secure views in Snowflake, but they do two things. A, they are not transparent about what they do to the user. The user can't see what exactly the query of the view is. And the second thing is that they eliminate some optimizations, which is not good operational-wise. So you cannot get hints about data that you're not supposed to get to have access to. So now we implemented a very simple column-based access control. We restricted the access from sensitive data from our packing teams. And we created the interface or the abstraction layer between the employees in the packing team, the users, and the data. So So that's pretty sweet. Data access control in Snowflake, it's a wider topic than that. I'm sorry, but I had to pick my battles, and there's a lot more like dynamic masking, like row-based access control, but it has some limitations. First of all, it's challenging to manage, especially in scale. And some organizations also use multiple data stores, not only Snowflake. That makes it even more challenging. But imagine that you have thousands of tables and hundreds of users, for example, and some of them need different restrictions than others, then it can become a bit complex to manage, to give permissions, to take away permissions, etc. It's not dynamic, as in, when I'm saying dynamic, I mean, for example, based on the data types. So I want to mask or restrict access to anything that contains a social security number, email, name, etc. So it's only very specific. And it's very easy, not only in Snowflake, but it's very easy to become over-permissive. And that's, I call it the silent killer of security, over permissions. When you have an organization, when you're in an organization long enough, you have more access than you need, because when you're in the security team or data team, people always come to you when they need access, but I don't know a lot of people who come back when they want that access to be revoked. So this is a big problem, overprivilege. And if you want, I wrote a blog about it, and you're welcome to read. We also have a reporting tool of overprivileges at Satori. If anyone is interested, feel free. And let's discuss the third topic, being very conscious of our time here, being the last talk. So let's discuss logging and monitoring in Snowflake. So first of all, I feel that with security folks, why log and monitor is, we don't even need to ask this. We all love logs. We're very passionate about logs. First of all, it's a requirement to have logs, to have audits on data access. It's a requirement in many frameworks, in NIST cybersecurity framework, in other frameworks. So first of all, we need to have access logs. And also, of course, when doing incident response or when understanding certain events that happen, it's very useful to have logs. And for visibility, to know what's going on inside that black box of a data warehouse, which teams are using what resources, how much, etc. Not only for security reasons, also for operational efficiency. Keep in mind that someone is paying the bills for the Snowflake and for Snowflake, and sometimes it can be good to analyze what's happening. And like I said, to reduce overprivileges and to proactively find threats, find users who are pulling more data than others, etc., etc. Well, we all know it. Analytics over logs is a killer. So logging in Snowflake, the good news is that logging in Snowflake is awesome. It gives awesome out-of-the-box capabilities without setting up S3 buckets you want the logs to be sent to, and which logs do you want to send there, and setting up ETLs over the logs, etc. So you're getting pretty good out-of-the-box capabilities. The logs are very detailed. We'll see that in a while, and they have a long retention period of 1 year, which is very cool. Some organizations need more than that, and well, for that you need to work a little bit and move the logs at least to your normal Snowflake account, or you can move it outside. But it has a long retention period, and this is very important also for organizations who find out, the oh shit moment, where you say, okay, I know that I needed to have this, but do I have it? And in some platforms, it's not there out of the box with a long retention period, and then you're just, oh, I'm sorry, I don't have logs for that time. and that's an awkward sentence to say, and you don't have to say it with Snowflake. And it's easy to access. It's just a SQL query away. They're in tables, in SQL tables of metadata that you can access, and that's very cool. So Paper Concatenator wants to leverage these logs, and if anyone is interested about the specific locations of such logs, they're both in the Snowflake documentation, and I can also answer that to the best of my ability. They want to know two things. One, if you've watched Phineas and Ferb, and I'm hoping that some of you did, where is Perry? Perry the platypus is always up to no good. So we want to know what he was doing, and keeping up to date. We'll have like a sample table for reporting. So let's do that. So let's return to our account admin role that we're using, and let's select from the query history all the queries by Perry Platypus. And as you can see, he was selecting data from paperconcatenator.secret.ultrasecret stuff, which is very typical of him. So that's one thing. Of course, this is just an example. And you can see in here that you have tons of data about the cost, about the credit cost, about the error messages that you got, and you can make aggregations, of course, and we can correlate that with other information. So you have a lot of things to play with. And the second thing, this was from the query log. This is from the login history or the access log. And in here, we'll do a short aggregation of which users got the most failures, login failures, and the reasons to these login failures. So this is just an example, of course, a very simplistic example, but you can, of course, figure out lots of more useful things to do in there. Some of the limitations around the logging, first of all, it's the retention time, which 1 year is a lot, but sometimes you may need more. It is raw data. You need to do, you need to work in order to get, value out of it. You need to do some work, and that's the only downside of the Snowflake logs that I could think of. Some general takeaways, and then we'll open it up for questions if we have time. I think we have time for at least a few. So first of all, Snowflake, the security controls in Snowflake rock. They are great. First of all, it's SaaS, so you don't need to worry about a lot of things you're getting out of the box. You're also getting good out of the box logs and retention, and you're also getting abilities to set up fine-grained access controls, column-based, row-based access controls, and of course there are more features that we still didn't discuss. Maybe next year. I will say that implementing a layer of security on top of Snowflake and other data warehouses, like we do at Satori, provides additional visibility, reduces overprivilege risk, and detects threats. Also, it makes it easy when you have more than one data store because it's decoupled from the data infrastructure itself, and it gives better access management. So that's also a point of consideration, of course. Now what? First of all, I know that I was speaking fast, so if you want, you can also read more. In our blog, I wrote a guide that's a bit longer than this talk. About you can look for the frozen heart-shaped padlock, and it's a Redshift hardening guide. There's also a BigQuery and not a Redshift hardening guide, a Snowflake hardening guide. There is also a BigQuery and Redshift hardening guide that I also wrote, and of course, feel free to keep in touch using email, LinkedIn, Twitter, or of course, Discord. So I hope you enjoyed, and I must say that it was very strange doing this talk without seeing anyone. So I'm hoping you truly enjoyed. And I have to say that the organization really kicks ass for a virtual event. That was really, really great. Everything is really super. So, and also the talks that I saw were great. So amazing. Now
Well,
is
thank you very much.
mute for the entire time.
No, you're great. You're great. Thanks. It's something that's definitely foreign to me, but people are responding well, and thank you for it. No questions as yet, but yeah, thanks for the talk. I have to say that I called the agent P thing. Actually, I called him Perry, and then somebody corrected me saying that the attacker would be Agent P. But yes, good job.
Right. Should read It's been a while since I saw Phineas and Ferb.
No, it was a fantastic talk. We really enjoyed it. And that's it. That closes out kind of the first day of BSides Toronto. So we still got another